Hi, I'm Didier Roche and I'm going to talk to you about Snaps, which is our new Linux cross-distribution application packaging format. To start, let's talk a little bit about the traditional Linux packaging. You can see the traditional, Linux packaging to be really handcrafted. It's really hard, to package properly, and it really takes a lot of time and love to be able to do this. We have special format for each transportation, or I would say distribution. For instance, let's say this package is a DEB, and you can only travel by airmail. Some other, like RPM, will be, for instance, for train. Some other as well will be for boats, like Docker containers. So the fact that we have different formats will force the developer to learn them all, to be able to deliver, their application on various platforms. Or what we see as well is that they will only deliver, packages for the most popular distributions. Or as well, they just give up on Linux. In addition to that, you need someone with special power to pick and do the delivery for you. So this is the maintainer for your Linux distributions. The maintainer basically is your gateway to the distributions. And as an upstream, you don't really know when the new version will be available, as it all depends on the transporter and their own schedule. So this really beautiful, package that a lovely specialized packager took time to do lives as well in an unknown context. It's really frightening. Like the packager context is not, necessarily the user context. Indeed, like packages, live alongside other packages, and we are not always sure about the version of those other packages that are next to them. And this is how bad things can happen. Like this. Collisions. Like those, poor packages can be damaged. Some example is that they can ship, the same files on the file system than other packages, and so you have this kind of collision. Also, they can be incompatible with each other, like different versions of some libraries, change their APIs, or, just their behavior. And, the package or application trying to use, this library in some unexpected way. Basically, you can have a breakage, even if you didn't upgrade your applications. And in the worst case of incompatibility, everyone, can make your whole plane or ship thinking. And the fact that, all the packages can influence the whole system, they have root access, on your system, and they have access to the entire read and write, to any files on your system. So basically, they can really, influence the whole system, and the whole system starts to be damaged. So the fact that this, in addition to have this package installed as root, and so having all the power when, they start to be installed, your whole system can be hurt, and this is because there is no application isolation. And this is for all those reasons that we created a Snaps. But first, before, talking about the advantage of a Snap, what are Snaps? So Snaps, you can see them as one Squashfs file. A Squashfs is just an archive, basically. Just one file, compressing the whole content. This gives us, transactional updates, integrity of content, compression, like the size of the Squashfs file is 1/3 of unpacked size. And as well, it's read-only. So as you can see here, we have the whole orange box is the Squashfs file, and inside you have some code. This is a snap, and the Squashfs file, is the code and assets, the gray one. Snap can ship one or more services alongside with a command line tool, some UI tool, and so on. So Snap is just not one process, it can be multiple processes. In addition to that, the Snap have access to some writable and readable area. And we have two kinds of area. We have one which is only which is shared by all the users of the system and only writable by root, and this is mostly for services. And we have a couple of other ones which are, for the user. And basically, each user will have its own directory dedicated for the snap. Some paths are version, so it means that every version of a snap, every time you upgrade your application, you will have a different version directory, copying the old data at its upgrade. And you have a common directory, which is common between all the versions of the snap. In addition to that, each processes are isolated from each other. So, for instance, each one has its own temporary directory. And they are isolated as well from the system. So they can see like the root of the snap itself is coming from an Ubuntu Core snap, which is going to be renamed Core soon. And this it has access to the host, but really, in very limited way in some special directory. As well as you can see, it can access to some other directory and files like the home directory, /dev, /device, /sys, and so on. But those are forbidden by default. And the snap can access, basically to have access to some devices. But this is under control. And by default, the application is confined. So they see a slightly different file system hierarchy, and they can have some access denials. The consequence of all this is that it's really easy, to update and to roll back, including data, independently each snap. And this is very, very, very powerful compared to a traditional Linux packaging system. So as I told, snaps are confined and isolated between each other. So basically you can see that each snap has its own, writable area. And we have some isolation between the snaps through AppArmor and subcomp. The application can't even read other application files. So it's really, like a very advanced, powerful mechanism, which is giving to us a fine-grained control. For instance, as I told, snaps can have multiple services and commands, and they all share the same file system. But even if applications from the same snap, can send signals like a kill process or a sig up and so on between their own processes from the same snap, they can't do that between different snaps. So snap A can't, kill a process of snap B. And this is forcing the snaps to request and expose clear and defined interface to be reusable between other snaps. So snap A can communicate with snap B through an interface, and one is using a plug to plug into the snap B slot. And as well, there is no script which is running as root by default. So now that we have a clear idea about what a snap is, let's see a little bit about the benefits of the snap. So one of the first snap we have in our store is VLC. It is a really popular video viewing tool. And what Upstream really liked about Snap is that it's really easy for them. It's really an easy packaging system. They only have to package it once and to be able to deliver to all distributions. And they are in control of their version delivery. So they know exactly which version of which library they are shipping, because the Snap will ship with all their dependencies. For users, while they benefit from the latest version, like independent of the distribution they are using. So all the distribution logos you can see are the one supported Snap as of now. And so if you deliver a Snap, basically you will be able to be installed, on all those distributions. And so you only have one version to support. Another happy Snap, upstream user is Nextcloud. For them, it enables to alleviate distribution version fragmentation. They are in control of their update, and they can, they can decide exactly when they deliver a new version. As I told before, in Snap, you are in control of your dependencies. So basically what is shipped in the snap is really what the user will get. And this really reflects to Nextcloud because when they were still named OnCloud, they went to a lot of distribution mailing lists requesting to remove their old OnCloud package. And why did they do that? Because for them it was a very ancient version that doesn't reflect the quality at all about what OnCloud was at the time. And distribution were a little bit trapped because they couldn't update OnCloud itself on the stable version because it requires some new libraries of limbNSS, which is shared with a lot of applications. And we have some upgrade incompatibility and fear, basically to break all the other applications. So this one really reflects to them. And the fact that Snap have application isolation enables the Nextcloud box to install third-party applications. So the fact that you can install, on a device multiple snaps, basically, can create very interesting synergies. For the users, you get the exact version that the developer tested. So you won't have an unexpected crash normally if the release is well done. As well, you have a robust update process with rollback, which is important in the case of Nextcloud because Nextcloud enables you, to save your data and to backup them. And in case, like something bad happened with a new update destroying your data, the fact that you can revert, and as we revert the data as well, we ensure that you will get compatible version of your data with that application. And it's quite important when, you trust the system to store, your own personal data. The third one, upstream I wanted to talk about was Rocket Chat. What Rocket Chat really like is that they can upload different versions of the same, Rocket application, but in different channels. So we have different channels with Snap. We have Edge, Beta, Candidate, Stable. And so they can have a daily build of Rocket Chat, for instance, uploading automatically to the Edge channel. And we can have some users who are opting in, for the Edge channel or for the Beta channel or for the Candidate channel and so on. So this is a really powerful system, basically, to be able, to have QA, for instance, testing the candidate before it's hitting stable and so on. So they can be installed on multiple systems. And for instance, Rocket Chat was, installed on the Nextcloud box as well. So you can have your own private chat system alongside with your own backup, data saving system. For the user, they can easily, be a beta tester, just opting to the beta channel, and if upstream, ship snaps here, you will get it. And they can install alongside any other package, like if you look at Ubuntu software, the UI basically shows Snap and debs at the same time. And so you don't even know by default if you're installing a Snap or a deb. We have as well, a command line for this. And so Rocket Chat configuration time, thanks to have, this very isolated Snap, went from 3 hours to less than a minute. And we went even further. We have Ubuntu Core, which is a new redemption of Ubuntu. And this is a whole Snap system. So what does an whole Snap system mean? It means that everything on the system is a Snap. And I mean really everything. So you see here we have, multiple snaps. The whole system is read-only. And we have the base interfaces provided by the core snap. So the core snap enables you to have the base system functionality, to have, the snap system itself, and to have access to some of the hardware. So the core snap basically is the base logic of the system. We have as well, the kernel snap. So the kernel, the Linux kernel itself, it's in its own snap. And so basically it means that enabling another board, it's just a question of removing the kernel and pushing, another snap, another kernel snap instead. We have the gadget snap. The gadget snap is customization and configuration of the device. which can specify some rules like which snap to install by default, which store, to target, and so on. Application snaps, this is what we saw in already. So the application snap are just, installable like on any other snap system, like the Ubuntu desktop, for instance. And they can share some content from the same author, the same developer, so that, they can reuse the same libraries between their own snap. But they're still in control because it's only private to them. So the content interface snap is a way to share some data and to share as well some libraries. But again, this is private to the developer. So each piece, each snap is independent of each other. And so we can upgrade the kernel snap, for instance, without upgrading anything else. Or we can upgrade one application without upgrading anything else. Everything can be updated and rolled back independently. Also, they can track different channels. So for instance, we can have one application tracking the beta channel, and the rest are just, tracking the stable channel. So this is really especially great for IoT devices because we have code integrity ensured by signed read-only squash-fs archives. And as well, every time we change an application, we don't need to rebuild the whole image, we just need to rebuild one snap and to change it. So I really encourage you, to strap Snapd yourself. But, just before getting into it, let's have a look at a little demo together on how to use Snap. So let's dive into this demo. You have all the instructions on how to use this demo on the associated slideshow. So we see the presenter in the video notes. But I'm going to do, it live for you. So let's open a terminal and maximize it. First, let's try to see, which snap you have. So I'm on Ubuntu desktop 1604 LTS. Ubuntu Core image can work as well, or if you have any of the distribution where you install Snapd. So let's look at a snap. I'm going to snap find hello to find the hello snap. You see that there is multiple hello snap published in the stable channel. By default, it's looking at the stable channel only. And I'm interested into that one, which is version 2.10. So let's install it. Sudo snap install hello. If I'm logging to the store, I won't have to be root to install it. So it seems that it's already installed. So let's run it. Hello. Okay, hello world, quite unsurprising. So hello basically is a GNU hello version, just packaged, as a snap. Let's see if it's really installed. Snap lists, you can see that I have some of the snap here, and as part of them, you can see that there is a hello snap, which is version 2.10, which is the information version. This is for the user only. Revision is an internal field, which always increment. And the developer for this one is canonical. And so we can have, various developer name. As I told, in the previous presentation, Snap can ship, multiple binaries. So you have the hello one and you have the universe one as part of the hello package. So basically, if the binary has the same name than the Snap name, it will be just shortened in hello. And if there is other binary name, it will be namespace by the hello snap. We'll see that again, a little bit later on. So hello universe is just, writing hello universe. So all the snaps on your system are refreshed automatically. So I don't have to do anything. The refresh, happens daily. And for an IoT system, it will even reboot it if, the kernel or the core snap, refreshed. I can force a refresh with sudo snap refresh. And it says that all snaps are already up to date. I can as well switch channels, with a refresh command. So if I sudo snap refresh, and I know that the hello package has another version in the beta channel, say --beta, you can see it's Now revision 29 instead of 20. And the version is slightly different, 2.10.1. Let's run hello now, and you see that the string changed. It's hello snap padawan. So let's remove now this package, sudo snap remove hello, and go on a little bit more interesting demos. We are going to install a demo which is doing face detection on cameras, and as well have some interesting features. So let's install it. Sudo snap install face detection demo -beta. I have to add -dev mode here because we don't have yet all the interfaces that this snap requires, and so the application is not confined that way. So be aware when you install such snap that using -dev mode gives them more privileges than a normal snap on the system, and so you are less confined. So let's install it. You can see that the snap is 35 megabytes. And we are going to let it install, quietly. So this snap is composed of some application command and a service. So it will automatically start the service as part of it. If we open a new tab, like this. So if I open a new tab on localhost 8080, you can see now that I have an interface, which is the face detection demos snap. And you can see that there is no screen capture yet. Face detection is off, fun mode is off, and the active camera is 1. I'm going to switch to my second camera actually here. And it's using WebSocket, so if you have a mobile phone or anything listing on the same, pointing the same IP, you will see all the changes reflected dynamically. So let's turn on, face detection. For that, I have a command line as well as, what you see on the web interface, which I name face detection demo. And so if I run -help, you can see that in addition to changing the camera, I can enable the camera. So let's enable the camera. And now my camera is enabled, as you can see. And it's starting to try to count faces. So if I point, to my second screen, you can see some, small circles here showing you basically, like the number of faces that are detected. You can see that we have 40 faces now, a little bit less. It depends if I'm, like moving or not. But it's not all, like this is quite fun to be able to play with these settings, but let's try to turn this, fun mode. So let's turn the fun mode on. And you can see here that, like the small yellow circle is replaced by distribution logo about the number of distribution we support, in Snap. And so now, people faces are replaced, with distribution logos. And you can see it keeps, counting faces, faces, and faces. And I heard that we have a new version of this application, this awesome demo, in the Edge channel. Remember, I installed it from the beta channel. So let's install it. So sudo snap install, sudo snap refresh, sorry, because we are going to upgrade it. Remember my previous demo, face detection demo, -Edge, and this one is using dev mode as well. Dev mode snaps are only published on the beta and the Edge channel, knowing that snap find only shows the stable channel by default. So let's run this. And let's see now, like how the application updates. So it's downloading the new version now, as you can see. And once, the new version is downloaded, it will stop the service and restart the service as well. So it's almost done. So let's have a look of what's happening. So the service is stopped. Now it's restarted and oh no! The new awesome shiny version 2, as you can see, is totally screwed. It removed all my data. And let's look at, oh, the picture is horrible. Like you can see the smileys instead of logos or instead of face detection. And it's printing me, negative numbers. So it didn't, only destroy my data. It only printing, negative numbers. And this is where, like you are totally, blocked on a traditional packaging system because the data are gone. But remember that the data are versioned with Snap. So maybe we have a way. And for this, I guess it's a good, candidate for rollbacking. So let's try to roll back. Sudo snap revert face detection demo -- dev mode. And so it's rollbacking. As you can see, the service is stopped. And yes, as you can see, my old data here are restored, even the old, the latest, picture with faces detected. And I have popularity of the demo. It's not anymore, this new version 2 alpha, which was on the Edge channel. So it was able to restore my data now, and I'm back, to a safe state. So this rollback functionality is really, really powerful if, the application, is really critical to you in particular. To be able to revert to the last known good state is great. Of course, you will object that we store multiple versions of the same data, and indeed we do. But remember that first, the snap squashfs file is way smaller. It's 1/3 of unpacked files, and this is not unpacked on the file system. And remember as well that we have some awesome garbage collection system. And once we know that a version is working properly, we keep it. We keep, the latest and the last couple. This can be defined in the gadget snap. But we keep some versions, but not all versions, of course. Finally, I want to point out that the version is blacklisted. So if I try again, to refresh to that version, it will say that there is no updates available because it knows that I installed, the new version. And when I revert it, it means that I have to blacklist it. So if we want, to go back to that version, we can remove with some option to tell I want to remove exactly that version, and then I can refresh again. So it's a way, to get you back, to the broken state if needed. And let's remove now our service. Let's build together our first snap. The process is really easy thanks to Snapcraft, and I wanted for this demo, to go a little bit further than the very simple Hello World program. So let's try to build the face detection demo that you just saw. It's not a very simple example, but don't worry, I will get you, step by step for this. It's really interesting because it ships a service, it's shipping as well a command line and some assets in various areas. As well, it needs access to the network. So it's really, an interesting and complete, example. So let's go step by step on this. So we have a service, which is a face detection server. And this service is written in Go, has multiple Go routines. You can see it has, some light threads. So basically it's one process with multiple threads. And each threads are doing a different purpose. We have a web server, which is listening on port 8080. We have some WebSocket for, like a live update of the system. We have a camera detection and an image processing service, which is using OpenCV to detect faces. Unique socket listener to talk with the client. I will cover that. A database handler because we need to store, all the data that we are saving. The settings is for which camera to use, if face detection was enabled or not, last time we used it. So it's used, to store this kind of settings across, process restart. And all these codes, will live in the snap itself, which is installed on our case in /snap/face detection demo /version number. The web server is using third-party assets. So it's serving some Polymer JS application, which is using web components for HTML and JavaScript. And those are stored in www compared to the $snap directory relative to it. And also some image and XML assets like the logos, distribution, how to detect a face, and things like that. We are serving this web server and the WebSocket to a browser basically through the network. And so the network can connect, to the server. So the server listens to an address. And also the camera detection is using, /dev/video star to get access to the camera, to list them, and to be able to process them. We are writing some data on the disk. So we are using the service root writable area, which is snap data. And we are storing basically the last image and the last image with detection assets on it. So these are the screenshots. We are storing as well in a YAML configuration the settings, and we are using SQLite for our database. And so all that is in the version path, which is what enables us to upgrade and then to revert even if we removed all the data from the new version path. We have as well a command line, which is face detection client. This is a command line that I use, to enable the camera, for instance. We can as well, change which camera to use if we are setting up the phone mode or not. And it's using a unique socket via the protobuf protocol to communicate with the face detection service. Note that both binaries, the face detection server and the face detection CLI, are part of the same snap. One is a service and the other one is a command line tool. So how does this translate as code organization? We have all the Go code, which are the two binaries, in the same local directory. So this Go non-app, and this is what we are going to call face detection backend. Remember that we have some static local file, which are the assets backend that we are going to ship as well, logos and models and so on. And we have some HTML files and Bower components for the Polymer applications. And those live in another repository on GitHub, as you can see on github.com/ubuntu/face detection web. So we have some local code and we have some remote code. Again, the face detection server and face detection CLI are both Go programs, so we are going to compile them. The assets, we are going to copy them in the in their own directory. And for the web front end, it's using Bower, so we need to run some commands as well to compile, to Bower install, to install the web components, and to copy the assets as well. And those are coming from another repository. So basically we have three parts in our application, and this is how it's going to translate. I'm going again to demo you live the creation of this snap, but you have all the instructions to the attach slideshow as well. So you will be able to follow it, to reproduce it as you need. So let's go back to our shell. Let's create a directory. So mkdir face detection demo. And we need to have Snapcraft installed. I already have Snapcraft installed. Snapcraft is a tool used to create our snaps. I'm going to clone the local code, the code that is used, the Go code for our application. So it's https github.com/ubuntu/face detection demo. And I'm going to use the vanilla branch, which doesn't contain the Snapcraft packaging. Here we go. Okay, so here I have the code, I have the XML assets as well, and I have the images, but I don't have the web interface itself. So let's create our Snapcraft file. This can be done with Snapcraft init. and Snapcraft init create a snapcraft.yaml for us, which is a generic, like file. So we are going to replace some of the parts with what we need. So as a name, I'm going to use phase detection demo. Version, let's put it to 1.0. This is just a string, and this is really for humans. Like you can even go up and go down, when you install and you update to new version. This is more to say to people, this is a stable version, this is a default version, and so on. Remember, only the internal version string numbers is important. And so we always recommend, to use it as a string. So let's write a summary demo for phase detection statistic. And we can have a multi-line, description basically. So the multi-line description will always start with a pipe, or we can just have it, as a short description in the same line. But this is just, standard YAML. So this demo shows phase detection statistics with fun heads. And as part of our metadata, we say that the grade is default for now because we are not going to put it. It's not stable yet for us. And the confinement, as I told, is dev mode. So our metadata are now set. Let's add our first, golden part. So we are going to use we are going to name the first part phase detection backend. Source, we say that the source is local. And we are going to use a plugin. So plugins, Snapcraft plugins, as a way for us to be able to define some behavior when it's going to be the parts. So we have some Go plugin, we have a Node.js plugin, we have some Python plugin, we have some Perl plugin, and so on. So basically all the plugins are for specifying some behavior, and Go will know that he has to go build, go install, and so on. The Go plugin has some options. So if we run Snapcraft help Go, we can see the options for these Go plugins. And again, if you want to list all the plugins, you can use Snapcraft list plugins, and you have a list of the existing plugins. So we are going to use the Go import path to be able, and this is really Go specific, to tell that our local source actually is this package. And again, you have a description, on the help for each plugin on what options are used for what. We are almost done for this part. The last things, remember that we are relying on OpenCV. And so OpenCV is a C libraries. And we are going to reuse here some packages, some Ubuntu packages. So 2 Ubuntu packages to be able to build basically our OpenCV dependency. So build essentials to get a C compiler and lib opencv-dev to have our OpenCV header libraries. So parts, as you can see, are dependent of the build system. We are using the local source here. The Go plugin will say to go get, go install for us. Plugins can have special options, and we can use build packages to set, the build dependency of our package. Again, this is only our first part. Remember, this was, the Go, the Go client code. We have a second part, which is also local, and which are our assets for the backend. So I'm calling that asset backend. It's local as well. We are going to use another plugin, which is plugin dump. Dump just copy everything, basically. But we don't really want to copy everything. We don't want to copy the source code as well. So thanks to the snap keyword, which take a list. And again, this is standard YAML. So I encourage you to look at, YAML in case you want to know more about the syntax. We are telling we are going to copy the images directory and a file which is named front face detection.xml. And this will just take those two directories which lives here. So we have here the images directory, and we have the front face detection.xml, and it will just copy them to the final snap, thanks to this snap keyword. Last part, our website. Remember that the source of the website is not in the same repository. So we are going to reference it, and Snapcraft will fetch it for you, install Git if it's using Git, install Bazaar if it's using Bazaar, Edge, and so on. So github.com/ubuntu/face detection web.git. And here it will know automatically this is a Git repository. If it can't detect, we have another option which is named source-type, which will give you a way to specify which version control system it's using. We can also, use tar file. It's not really limited, to version control system. Here we are going to use a Bower plugin. And the last thing is organize. We are telling that everything which is in this repository will go to the www/. And this is basically a way for us to say that everything that we are going to install in this directory from this part basically will be installed actually on the www directory. So Bower plugin, if you Snapcraft list plugins, you will see that there is no Bower plugin here. Actually, you can ship your own plugin as well as part of Snapcraft. Here in the directory part plugins, you see that I have a bower.py. And this is a way for me to create my own Bower plugin, which is going to install Bower, to install the web components and so on, for me. This is really powerful. This is a way to extend Snapcraft to our specific needs for you. And there is a whole documentation on how to create plugins on snapcraft.io, but we'll come back to this. Okay, so it seems I'm done. I have my 3 parts, to be able to exactly install what I need. Let's try to build it. So let's run Snapcraft. Snapcraft is going to pull the code for each part, one after another, and process a build, process an install, and reassembling everything in the same directory. You can see that right now this is my local Bower plugin, which is doing Bower install and is fetching everything that it needs. Now it's going to go to the face detection backend part to pull and go get the code itself. And it will do again the same with the third parts for us. So again, we have multiple phases on Snapcraft. The first one is to pull the code, then it's going to build and install it, and then it's going to prime to stage them in the same directory, and to prime them to add the Snapcraft and the Snap metadata for us. Now it's running go install, and I didn't, as you can see, building was really easy. I didn't need to specify anything in particular. All the plugins are doing that for me, and so I don't need to have special makefile recipe for packaging. This is all declarative. So the staging part has been done and priming has done. And so in this prime directory, I have my final Snap content. So as you can see, I have a prime directory, and this is what is going to be in my Snap. What the snapping is doing basically is compressing everything from this prime directory in one file, which is using that name. So let's install it. Remember, we needed dev mode to install it. And now it's installed. So let's have a look if everything, went well. If I have a UI, it means that it worked. And as you can see, I don't have any services. Let's try, as you can see, I don't have any face detection demo as well. What happened? Actually, in Snap, we need to expose explicitly binaries and services for us. And this is what we didn't do. So let's do that. By default, no binaries are exposed to the system. So let's add the apps stanza to declare our applications. Let's create the first one that we are going to call tool for now. And I can say this tool is using one command, and the command is named face detection client. And we are declaring a service as well. And the service is using one command, which is face detection service. But remember, this one is a daemon. So we need to say this is a daemon, and this is a systemd syntax to say daemon simple. It's a simple daemon that doesn't fork or doesn't do anything, but it will transform it as a daemon for the system. And we want to say, even if we exit 0, please always restart this daemon. So I have defined, two applications that I named tool and service. One is referencing to the face detection service daemon simple, and the other, the tool, is just a command which is going to exec face detection -cli. Let's rerun Snapcraft. You can see that Snapcraft has some smart caching basically. So it did cache everything that was pool, build, stage, prime of the other parts because we don't need to rebuild anything. It's just adding the metadata and creating the wrapper script to run our new commands and to expose them. So let's install the new version. You can see that the new version is installed with a version which is X2 and it's in dev mode. When you are installing from the store, it will be version 1, 2, 3, 4, 5, 6. Local install version is X1, X2, X3, and so on. So, is it better now? Yes, it is. So as you can see, here we have again, the UI, which is working. And this UI is exposed through the service. So the service has been started and so on. Let's try the command line tool now. And you can see that the command line tool is named face-detection-demo-tool. So it's using the snap name dot command name. So the app name that I gave basically. And let's try to run it, you can see it's running. So basically face snap name dot application name. So let's try to make this a little bit more pretty because we are only using one. So if I matches the app name to be the snap name, so if I put here the face detection demo, and again I just rebuild it, the fact to match those two names will enable us to have only face detection demo. It won't be face detection demo dot face detection demo because the two matches. It will just shortcut it in one. And this is what happened in our very first example with Hello. The Hello program was hello.hello and we had hello.universe. But hello.hello was made shortened because the two names were matching. So they are only exposed as hello. So if I install that version again, now instead of having face detection.tool, face detection demo.tool, I only have face detection demo. And you can see the minus help works that way. Thanks first, for looking at this demo. I hope that it got you excited, to create your first snap and to play, with the snap and so on. We have a lot of resources for users and as well for developers. So snapcraft.io is a base website, basically to learn about Snap and to learn how creating Snap. We have developer.ubuntu.com, which is more specialized in Ubuntu Core itself, so the old Snap version of Snap. You can as well contribute. Snap and Snapcraft are, some open source projects. So you have the links for both, GitHub repositories here. And finally, if we want, to learn step by step as well, we have some code labs, which are step-by-step guides, tutorials for you. And they are packaged as a snap. So you can just sudo snap install snap-code labs. Head your browser over localhost 8123. And you will get, like those nice, very craftily packed, tutorials. We have some additional slides on the slide deck, which are the FAQ. So in case, you have remaining questions and so on, I really encourage you, to go to the slides and look at, those FAQs. And I hope this can answer your questions. On snapcraft.io, you will have as well links to join the community, to join our mailing list, our IRC chat room, and other resources like that, and how to get in touch with us. Thanks again for watching, this demo. I hope it was interesting to you, and see you soon.